All right, here we go. Questions, first of all. Everybody submitted their homework. Did that process work okay? Everybody figured it out, submitting it on Moodle? We're good? Yes? Okay. My goal is I really don't want to grade your homework on a computer screen. I've stared at a computer screen, I don't even know how much, the last week or so. So my plan is to go into WLC, which I'm allowed to do because I am essential for distance learning, and print off your homework, and then I'll scan it back in for you or take a picture of it or something. But I would very much like to grade it by hand. So hopefully that will happen this weekend. I am, however, no, you guys can be a priority because you have a test next week. I have homework due in every single class today. So I'm getting a ton of homework today. It's fantastic. But I will get yours graded hopefully this weekend, and then I'll email it back as an attachment. So that'll be the plan for that. Okay, that's the first thing. Second thing, test next week, Friday. So any questions in general on the test next week, Friday? Procedural, content, etc. Anything there? Yes, no, maybe, no, everybody's good.
Sorry, I was unmuting. I was eating cereal, so I didn't want to be loud. But I was just gonna ask, do you think at some point before the test we could do like a couple more contradiction problems? Because
sure.
like on the homework, those were
like
a struggle.
Those are hard. They definitely are. Remind me on Wednesday, and we can do that as part of the review when we go through. Yes, proof by contradiction is hard. And if there is anything for proof by contradiction on the test, it'll just be one problem. And I promise that I will tell you that you have to do it using proof by contradiction. The other proof techniques, I won't necessarily tell you what technique you need to use, but proof by contradiction, I will tell you that I want you to use that one. So, other questions, procedural, content about the test, anything else? Grace.
Okay, so when I was doing the homework, I feel like a lot of the proof by contradictions ended up being the contrapositive way. Is that normal?
Yes, and this is where I am more of a stickler than anybody, not anybody, but a lot of other people are. So yes, a lot of times a proof by contradiction will end up contradicting one of the hypotheses, and then you'll make it into a proof by contrapositive. Many mathematicians don't care, and they'll say, oh, I came up with a contradiction, that's great, we're done, proof by contradiction. I had a friend in grad school who was like, on this bandwagon, no, it is not a proof by contradiction, you have to rewrite it. So if I ever write a textbook, which I probably won't, but if I ever write a textbook, then there'll be real proof by contradictions. If most other mathematicians write a textbook, they're probably going to turn into proof by contrapositive, a lot of them, because they don't care as much. So yes and no, normal, depending on who you talk to. I just talked a lot about math, and I'm not sure how much I answered your question. Does that answer your question, Grace?
Yeah, but so we should change them over.
Yes.
Okay.
If you didn't on your homework, that's okay. I'm not super concerned about on your homework if you did or didn't. And on a test, if I tell you to use proof by contradiction, I promise it really will be a proof by contradiction. I won't give you one to do by contradiction on the test and then say, oh, make it into a proof by contrapositive. Okay. Other questions about the test? Okay, then today, let's go to share whiteboard here. We are going to do section 7.2. There's my whiteboard. Sorry, there we go. So today, and again, I can't see all of you now, so if you have a question, you're going to have to virtually raise your hand. Maybe I can see you. Let's see here. I get my grid going all the way. Oops. Sorry, the joys of figuring out technology. 1, 2, 3, 4, 5, 6. Oh, I can see all of you. Okay, I can see all of you, but you still might want to raise your hand virtually because I'm not necessarily watching you. And now we've got a straight mark on the whiteboard. That's sad. Okay. Thank you for being patient with me as I figure out technology here. Section 7.2. Equivalent statements. And remember, you can take notes live if you want to, but all of my chapter 7 notes are posted on Moodle. So if you don't want to take notes live, that's totally fine too. You can do it either way, up to you. All right, so remember, first of all, we had biconditionals, right? So first of all, for a recall, a biconditional, that's a fancy way of saying if and only if. And I don't like if and only if because it takes too long to write, so we do an IFF. That's a biconditional, right? Biconditional, and remember that my arrow, or the way that I represent this, is P, if and only if Q, biconditional. Remember that this basically turns into two proofs, so you need to show two things. You need to show that P implies Q, and you need to show that Q implies P. That's all review from Wednesday. Everybody's good on biconditionals? Review on biconditionals from Wednesday? Everybody's good there? Okay. So a biconditional is another way of saying that P and Q are equivalent. So that's another way of saying biconditional and P and Q are equivalent. Think about the truth table, and somebody asked this, I think it maybe was Grant at the very end of class last time. If you look at the truth table for a biconditional, we'll do it the short way. So we'll have true, true, false, false, true, false, true, false. And then the biconditional truth table is true, false, false, true, right? Biconditional, remembering the truth table for biconditional, everybody remembers where that comes from. And if I box my last, oh, sorry, this one's not so good. If I box my last column. So a biconditional is true. P, if and only if Q is true, when P and Q have the same truth value. And this is one of them that I asked you in your reading assignment, and everybody was pretty good with this, but I want to emphasize it one more time because we're going to need it when we get to biconditionals of more than two statements. So true in the first line, P and Q are both true. True in the last line, P and Q are both false. So that's what an equivalent statement means. P and Q are equivalent means that P and Q have the same truth value. Okay, so everybody's good there. Yes, we're happy, we're good. Equivalent statements, when I'm talking about two of them with a biconditional, that they have the same truth value. Give me a thumbs up, everybody's good there. We're good to go and we can move on to more statements. Yes? Okay, cool. Whiteboard screen number 2. All right, so now what we want to look at is equivalent statements. With more than two propositions or statements or whatever you want to call them. More than two propositions. So when we are doing equivalent statements with more than two propositions, we can't do a biconditional because there's a whole ton of biconditional arrows that would need to come in, and it's going to get way more complicated than we want it to. Instead, what we're going to do is say the following are equivalent. So our equivalent statements say something like, the following are equivalent. And so we usually label them with numbers. I'm just going to go with number 1 is P, number Q is Q, and number 3 is R. So we'll talk about what that means in just a second. We're going to do a specific example with some specific equivalent statements in here in just a sec, but I want to talk about the general method for this working first. So the following are equivalent means that P, Q, and R are all true, or P, Q, and R are all false. That's what equivalent statements mean when you have more than two equivalent statements. All of them are going to be true or all of them are going to false. In other words, all of them have the same truth value. It's the same thing as with P, if and only if Q. We're just doing multiple statements in this case. So the way you prove this, to prove, and by the way, the following are equivalent, usually gets abbreviated because that's a lot of stuff to write out. So usually I'll abbreviate this as TFAE, or sometimes, I don't do this if other books do, these are equivalent. They leave out the F. So these are equivalent. Whoops. These are equivalent. So you can do the following are equivalent or these are equivalent. Okay. So if we want to do a proof of the following are equivalent, the easiest way to do this is to visualize a graph. So we're going to put statement number 1 here. This is P. We're going to put statement number 2 here. This is Q. And we're going to put statement number 3 here, and this is R. I'm going to draw some arrows in just a minute, but we're going to draw a basic graph. Remember, a graph is with lines and arrows, not with X and Y axis. So I've got 3 different biconditionals basically going on here. So I need to prove that P implies Q, and I need to prove that Q implies R. I need to prove that P implies R, and I need to prove that R implies P. And I need to prove that Q implies R, and I need to prove that R implies Q. So you have 3 different biconditionals that you're working with, which means you have 6 different proofs that you are going to need to do. Anybody looking forward to doing 6 different proofs when we have the following are equivalent, you're totally allowed to say no at this point in time. Anybody looking forward to doing 6 different proofs? I'm getting some head shakings. Okay, so instead, here's my instead. Here's how we can do this instead. Basically, what you have to do is be able to get all the way around the circle. So instead, and you can put these arrows in anywhere you want as long as you can get from any one statement to any other statement. So for example, I could prove P implies Q, I could prove P implies R, and then I could prove Q implies R. So if I want to get from P to Q, that arrow's there. Fantastic. I am good to go. If I want to get from P to R, that arrow's there. That's fantastic. I'm good to go. Everybody hanging with me so far? If I want to get from Q to P, can I get from Q to P using these 3 arrows that I've drawn in this case? Is there a way to get from Q to P right now? Yes, no, maybe? Give me a thumbs up or thumbs down. Is there a way to get from Q to P right now in this instead picture that I've drawn? Is there a way to get from Q to P? Thumbs up or thumbs down? What do you got? Thumbs up, thumbs down. Grant's giving me a thumbs down. Nobody else is volunteering. Lauren is giving me a thumbs down, so is Josh. Okay, all right, so I'm gonna need to add another arrow somewhere. There's a couple of different places I'm going to add another arrow. I will choose to add one here. So now I can get from Q to P, right? I have to do it in 2 segments. I have to go from Q to R and then from R to P. But the point is I can get from Q to P in this instead diagram that I've drawn. You can check the rest of them, right? And it should work that you can get from anywhere to anywhere else. So I can get from Q to R, obviously, no problem. I can get from R to P. Obviously, no problem, there's an arrow there. How about from R to Q? In my instead diagram here, can I get from R to Q? Thumbs up, thumbs down, R to Q. Can I get there? Thumbs up or thumbs down? Yes, good. It's gonna take 2, but that's okay. So instead of doing 6 proofs like I have over here, I can do 4 proofs in my diagram in this one. Or I can make it even shorter and I can just go around the edges. So this is instead number 1. We could also do instead number 2, and we could do P, Q, R. Let's go from Q to P, and P to R, and R to Q. So obviously I can get from any one to any other one in this instead number 2. The instead number 2 is going to have 3 proofs associated with it. So for instead number 2, what you would need to show is Q implies P. You would need to show P implies R, and you would need to show R implies Q. Those are your 3 proofs, and then you can figure out how you want to prove each of those, whether you want to do a proof by contrapositive, whether it's a direct proof, proof by cases, proof by contradiction. So we've got 3 proofs in our instead number 2 as opposed to 6 proofs in our basic to prove the following are equivalent. All right, I'm going to stop sharing my whiteboard for just a second, and then I can see all of you. Let me see if there are questions at this point, and if not, then we'll do an example of one of these. So, any questions at this point in time? Anything for questions on the following are equivalent? Does it make sense that, again, it's stuff we've totally done before, you just have to break it down into your individual proofs and see where you want to go? Doing okay? All right, cool. Let's stop the recording there, and I'll start it again.